Welcome students, I am Raman Singh Chauhan. We are going to study today's topic polarization of light. So what is polarized light? Before we go on polarization, we will learn about what is polarized light and what is unpolarized light. The light directly from the sun or other sources, and unpolarized meaning the electric and magnetic fields oscillates in many different planes. That is, we can say when we are considering a light from the sun or any ordinary bulb, what we can see that the vibrations of the light, because we know light is electromagnetic wave, so it is having electric field and magnetic field, and when we are considering the polarization, that is optical property, then we are considering electric field or electric vector. So we can say that the vibrations of electric vectors are along all the directions in the space. We can see in this diagram that the vibration are along this which are shown, but there are vibrations in infinite directions. So these are the electric field orientations shown here. That is the directions of vibrations of electric vector, you can say. So we can say when we are considering unpolarized light, the orientation is of electric field is in all the directions, and when we are confining all those directions, or we are confining the electric field orientations or the vibrations of electric vector in one plane, then that light is called polarized light. Polarized light refers to light in which all waves have electric field oscillating in the same plane. That is, if we are doing anyhow, we can do, or we can confine all these vibrations in one plane only, whether like this or this or this or this, then we can say that the light is polarized. In fact, in general, what we can say that polarization is lacking of symmetry. That is, you can see that when we are considering unpolarized light, in case of unpolarized light, the vibrations are in all the directions, and if we consider this light, we will see that there is a symmetry existing for the vibrations in all the directions. But when we are taking the polarized light, in case of polarized light, that all the vibrations are in the fixed plane or in the same plane, and beyond that plane there are no vibrations. So what we can see that the symmetry of the vibrations is lacking, or that is broken, and that is why this is called unpolarized light, polarized light. So now polarized light, a polarizing filter is made of a material with long molecules that allow electromagnetic waves of one orientation through. That is when we are taking polarization filter, or if we want to create polarized light, then we are using polarization filter, and in case of polarization filter, the specific orientations of electric field are only allowed, and the rest of the orientations or components of electric vectors are absorbed. So in that case, we can say that only transverse waves such as light can be polarized, because polarization is based on preferential direction. When we are considering longitudinal wave, then in longitudinal wave there is only one preferential direction. But when we are considering the transverse wave, then infinite preferential directions are there, and that's why in case of transverse waves only, the light can be polarized. Much of the light we see is at least partially polarized. So here we can see that maximum light which we are seeing, that is partially polarized, that is polarization up to some extent is there, but there is mixing of other planes also, vibrations of other planes. For example, when light reflects of surfaces, it is partially polarized. Some sunglasses containing polarizing filters which helps to block glare such as glare that is noticeable when looking out over a lake on a sunny day. So we can use polarization filters in sunglasses to reduce the glare of the sun. Unpolarized light, that is, we have already talked that unpolarized light is having vibrations of the electric vector in all the directions, that is, it is propagating in all the orientations, no particular orientation is preferred. When it passes through a filter, that only allows vertical component of electric field to pass, its intensity is cut in half. That is, when we are using any polarizing filter, in that case, only the component which is perpendicular here, the settings are such that vertical components of electric field are allowed to pass and others are blocked. And that's why the intensity of the light which is passing through the polarization filter when we are using the unpolarized light is half, and that we can determine by the consideration that if we are taking, because the light is symmetric, and if we consider that only two components are existing, one parallel component and one perpendicular component, then these two components will be having equal intensity, and that's why if only one component is getting allowed to pass, then intensity of one equal component, that is half of the intensity, is allowed to pass. That's why the intensity is cut in half. This is because on average the light is half horizontal and half vertical in terms of electric field component. So that we have already talked. This would completely block the remaining light, thus any two perpendicular filters will block all incoming light. Suppose now that the two filters are offset by some angle theta. Regardless of the angle, the first filter blocks half the light. If theta is equal to 0, the second filter has no effect. And if theta is equal to 90 degree, the second filter blocks the other half of the light. So we can see that now if we want to use two filters, if we are seeing light by two filters, and these two filters, these polarizing filters are at some angle theta, then regardless of the angle, if first filter allows the light or block the light, then half the component is allowed to pass, and if half the component is allowed to pass and the second filter is at an angle theta which is equal to 0 degree, then the same intensity, because the angle is 0 degree, that is parallel to the previous one or the first filter, then the component which is passed, that component will be having no effect because of this second filter, and the intensity which is passed through the filter 1, that same intensity will be passed through the filter second. But when theta is equal to 90 degree, then the second filter will block the component, because now it is perpendicular to the light which is passed through the filter 1, and that's why no light will be passed to the other side of the second filter. In general, when polarized light with an electric field of amplitude E passes through the second filter, the amplitude will drop to E cos theta. Furthermore, since the energy a wave carrier carries is proportional to the square of its amplitude, the intensity of the light will be the original intensity multiplied by cos square theta. So we can say that if any incident light which is having amplitude E of electric vector, then that E will be having two components for the filter 1, that is E cos theta and E sin theta. Since perpendicular component E sin theta will be blocked, then only parallel component E cos theta will be transferred or passed through the filter 1, and now this E cos theta is the amplitude which is passed through the filter 1, or that is the amplitude which is passed through the filter. The intensity will be proportional to the square of the amplitude, and that's why we will be getting I is equal to e cos theta whole square, that is I is equal to e square cos square theta, and e square is equal to I naught. So we can say I is equal to I naught cos square theta. So we can say that the light will be having original intensity multiplied by the cos square theta, and this law for determining the intensity when a light is passed through the filter or polarizing filter having an angle theta with the plane of vibration is called the law of Mallows. So we know that if theta is 90 degree between two filters, then no light will make it past the second one. At other angles, the light will pass through both, changing the orientation of its electric field each time. That is when angle between the two filters is neither 0 and nor 90 degree, then the orientation of the light will change and electric field will changing the orientation each time. So what if we arrange several polarizing filters so that the angle between any consecutive filters is less than 90 degree? The answer is that light twists its way through the filters even if the angles between the filters adds up to 90 degree. With each pass, the light is oriented in a new direction, and this new orientation has a component parallel to the orientation of the next filter. So we can see in this diagram that light enters here, and there are various filters existing, and because of these filters, the light will pass through, changing its orientation of electric vector, and at this point it will exit. So this is clear that we can see what is happening because of number of filters. Now polarization is a characteristic of all transverse waves. Oscillation which takes place in a transverse wave in many different directions is said to be unpolarized. In an unpolarized transverse wave, oscillation may take place in any direction at right angles to the direction in which the wave travels. So here we can see, if we are considering an unpolarized light, here the orientation in all the direction, vibrations are in all the directions, and this is the direction of propagation. So in this diagram we can see that the light is propagating and the vibrations, these arrows which are shown inside this diagram, these are the vibrations of electric vector, and they are rotating in helical motion in this light, and that is unpolarized light. Here we can consider, because in all the direction we are having vibrations. Now when we are taking linear polarization, if the oscillation does take place in only one direction, then the wave is said to be linearly polarized or plane polarized in that direction. Here we can see this is the direction of oscillations or vibrations of the electric vector, and this is the direction of travel. So, and this is depicted in this diagram also. Now, any electromagnetic wave consists of an electric field component and a magnetic field component. The electric field component is used to define the plane of polarization because many common electromagnetic wave detectors respond to the electric forces on electrons in material, not the magnetic forces. So, what we have already discussed, that polarization is because of is an optical property, and that's why it is dependent on the electric vector of the electromagnetic wave. So here we can see that there are two types of vectors shown. One wave is black and one is red. One is electric vector and the other one is magnetic vector. So the properties which are deciding this polarization are electric vector. So Polaroid. Now we will talk about Polaroid. A Polaroid filter transmits 80% or more of the intensity of a wave that is polarized parallel to a certain axis in the material called the polarizing angle. So Polaroid is made from the long chain molecules oriented in their axis perpendicular to the polarizing axis. These molecules preferentially absorb light that is polarized along their length. So here we can see this is unpolarized light and there is a pole light here, and when light passes through the pole light it becomes polarized. So what are pole light? Pole light are the substances or filters which produces or which converts an unpolarized light into polarized light. Now we will talk about polarization of reflection, that is method of polarization. In polarization by reflection, we can see when a light is incident on some specific angle, that is called the Brewster angle, then the reflected light is plane polarized and that is having vibrations perpendicular to the direction of propagation. So here we can see this is unpolarized incident light and this is polarized reflected light. So reflection of light of non-metallic surfaces result in some degree of polarization parallel to the surface. Now this is shown here in Brewster's law. It is found that experimentally when the reflected ray is perpendicular to the refracted ray, the reflected light will be completely plane polarized. So here this is incident light, these green dots are showing the vectors or vibrations perpendicular to the plane and these arrows are showing the vibrations parallel to the wave. So we can see that this direction is parallel and the other one is perpendicular to the screen. Now the angle of incidence here is theta p, that is polarizing angle or Brewster angle, and then the light ray is reflected here which is having only perpendicular vibrations, and here the light ray which is refracted at an angle theta r, this is this is having partially polarized light because the vibrations are in both the direction perpendicular as well as parallel to the screen. And here we can see this N1 is refractive index of this medium and N2 is refractive index of this second medium. So now by Snell's law we can see that N1 sin theta p, or we can say sin theta p, that is sin I upon sin r is equal to N2 upon N1. So from here incident angle theta p, we get N1 sin theta p is equal to N2 sin theta r. Since theta p plus theta r is equal to 90 degree and sin theta r is equal to sin 90 minus theta p, that is cos theta p, then we get tan theta p is equal to N2 upon N1. So in this way we get this Brewster law, tan theta p is equal to N2 upon N1. Now in case of polarization by refraction, when a number of plates are there and at every step the reflection is taking place, then ultimately we will be getting a polarized light at the end which is emerging with vibrations parallel to the screen. The two refracted rays passing through the Iceland spar crystal are polarized with perpendicular orientations. Now we will talk about double refraction. This is also one method. In double refraction we are getting two rays for one incident ray, and this depends on the property of the crystal. Such crystals which can produce two plane polarized light when one unpolarized light is incident on the wave. Here we can see the two images of this pencil. So one is E image and the other one is O image. E image is extraordinary image and the other one is ordinary image. When light is refracted into two rays, each polarized with the vibration directions oriented at right angles to one another and traveling at different velocities, this phenomenon is termed double or birefraction. Here we are seeing the calcite crystal and we can see birefringence here because we are observing the two images of this pencil. So this is all for today. Next topic we will taking in the next class. Thank you.